Okay, let's solve a couple log equations. We'll start with the one on the left. In problems like these, what we want to end up with is a single log on each side. So we want to use the laws of logs to take this left side and express it as a single log. And we know from the laws of logs that a sum of logs is just the log of a product. So I can write that like this. Now what I've got is the left side equal to the right side, and that's a whole log equal to a whole log. And if those logs are equal, then the contents of those log functions also have to be equal. And that's our key to solving this problem. So we'll just drop the log function off and write x times x minus 3 is equal to 7, and then solve that as a quadratic equation. Now this quadratic equation, I happen to know, can't be factored, so we'll have to solve it by completing the square. So I'm going to add half of that 3 squared to both sides, so I get plus 9/4 on the right side. And I'm just going to go ahead and convert the 7 into fourths. 7 is 28/4, like that. So if I write out my perfect square on the left, it's x plus 3/2 quantity squared, and that's equal to 9 plus 28 is 37/4. Take the square root of each side, so I get x plus 3/2 is equal to plus or minus root 37 over 2. Remember, I take the square root of the denominator also. So x is equal to minus 3 plus or minus root 37 all over 2. Now in these kind of problems, it's really important to take a look at our solutions or our potential solutions and see if there are any extraneous ones. So I'm going to estimate that root 37 as about just a little bit over 6. And so I get solutions that are approximately equal to 3.1 and minus 9.1. But that minus 9.1 over 2 solution is not going to work because we can't take a log of a negative number. So that's an extraneous solution and I have to throw it out. So I end up with one solution, and that is minus 3 plus root 37 all over 2. So that's the solution to that problem. All right, now let's tackle the problem on the right. This is a problem with natural logs, but we know that that's just a log with a base of e. So the same rules apply for equations with natural logs. Now in this problem, we have a log equal to a log, but this one on the left, we need to use the laws of logs to rewrite it. And the law that we're interested in is the log of x to the a is equal to a log x. So don't forget these laws of logs. This one allows us to either put a number up into the exponent or take it down, whichever suits us best. So in this case, I'm going to use that to write this as the log of x squared is equal to the log of 12x minus 27. And so now I have a log equal to a log, and that means that what's inside of those logs, the x squared and the 12x minus 27, have to be equal to each other. So just set those equal to each other to solve it. X squared equals 12x minus 27. And I recognize this, I think, as something that's factorable. So if I write it out as a quadratic equation with everything on the left, yeah, I can factor this. X minus 9 times x minus 3 is equal to 0. So I have solutions of x equals 9 and 3. And if I just check those out, there's no negative numbers there, so it looks like both of those solutions will work. We should always check those out to make sure that there are no extraneous solutions. And if there are, we'll have to eliminate those.